As Eric mentioned, thank you for coming out. I'm going to talk to you tonight about Ansible and some of the ways you can apply DevSecOps to some of the Ansible content that you manage in your environments. So for those who don't know me, my name is Patrick Freeman. I work for Red Hat. I'm a solutions architect. Basically, what I do is I help customers, I help partners connect the dots with the outcomes and the solutions that they're looking to build. I've been at Red Hat for about 3 years. I'm based in Northern Virginia. So if you ever want to, if you have questions or ever want to connect, please reach out. I'm happy to have those conversations. All right, so here's a look at what I plan to discuss today. First, I want to talk a little bit about Ansible, just to kind of lay the foundation for anyone who may be new in here. Then we're going to jump into a little bit about DevSecOps, just to lay a foundation for that as well, but also just to provide a basic understanding. This is not to teach you about DevSecOps or Ansible per se. This is just to lay that foundation. And then we're going to talk about some ways that you can introduce some of those DevSecOps concepts into Ansible and some of those practices that you can adopt with your operations that you're doing today. So after that, we're going to jump a little bit into the why and the how you want to do some of this stuff. And then we're going to talk about some of my favorite papers, some of my favorite briefs, some information that you can take with you to utilize to increase your knowledge around this topic. So before we get started, I just want to understand who we have in the room audience-wise here. Is anybody here in operations? If you could, raise your hand. Awesome. How about developers? How about database administrators? Network admins? Anyone else that I missed? All right, perfect. So when it comes to automation, a lot of companies, a lot of organizations, they have the same challenges. They're inundated with manual processes. From an operations perspective, just like we have different folks with different roles in here, we have, when it comes to automation, you have folks utilizing different tools. So the goal with Ansible is to automate some of those manual processes, but also, if you do it right, you can break down some of the silos between those teams and help the teams work together more efficiently by sharing the content, the automation that they're creating. So what is Ansible? For those who are, is there anybody, well first, I guess, is anybody in here who's not familiar with Ansible, never heard of it? Okay, so just to give you a refresher, so Ansible is an open source tool that allows you to automate things like your application deployment, your configuration management, pretty much any other manual task where either there's a CLI-driven way or a RESTful API-driven way to interact with it. It's powerful, meaning when I first got started with my automation journey about 10 years ago, we were just primarily focused on day 2 operations for the servers and the applications that we were supporting. But today, actually, Ansible can be utilized for many different use cases, from your networking team, your DevSecOps team, or your DevOps team. They can all be utilizing the same tool, speaking the same language when it comes to automation. And with that consistency brings accelerated outcomes. So one of the nice things I like about Ansible is it's also simple, meaning that you don't have to learn a complex programming language to be able to take advantage of it. You can start, it's written in YAML, so it's human readable. It's also considered to be self-documented in a way, so as new folks come on board and they need to figure out what's going on, be able to quickly see what's going on from a automation content perspective as you create your automation content. It's also agentless. Now, that's powerful because it's less you have to manage from an infrastructure perspective. Just to give you an idea, it also helps to reduce that attack vector when it comes to the different software that you have running your environment. So for example, a few years ago, we started, when I was working at one of my other companies, we had an automation software that had an agent. I didn't want to mention it because I don't want to take shots at it, but we got to the point where we were spending more time troubleshooting that agent, trying to figure out what's going on with that agent than we did with our application deployments and our day 2 operations. So with that agent approach, it helps simplify the operations from that aspect. So you can focus on those outcomes that you're looking for. So when it comes to security, there's a lot of challenges when it comes to security these days, especially these days more than ever. Security is becoming more and more important, right? There always seems to be some kind of security patch or some kind of security update that you had to push out. You got different teams, they're utilizing their different tools when it comes to security. You're lacking some of the consistency. You don't always have that visibility, that governance into the security that's in your environment. So one of the ideas is with DevSecOps is to shift left on security, to start introducing it earlier within that software development lifecycle, right? And it's also about changing the culture around your operations when it comes to how you handle security in your environment. You can think of it as also, I would focus more on the culture aspects, and because you really have to get buy-in for all your teams to be successful when it comes to DevSecOps. I mean, it all starts with some of those triggers, right? You have to make sure that you're versioning your software that you're running in an environment. You have to make sure that as you try to automate some of this, that you try to centralize on some of those tools that you may have in your environment. For example, like continuous integration, continuous delivery. You want to make sure that you're using some type of source of truth that provides you with that traceability as you're trying to adopt a DevSecOps model in your environment. And with Ansible, depending on like how you're running your automation, Ansible can be triggered from that CI/CD tool. You can also utilize other tools that may be available in your environment or may be available based on your needs to make sure that to have it trigger Ansible, for example. So these are some of the basic reasons of why you want to do DevSecOps. You want to, try to standardize those workflows. You want to get visibility and have that traceability into what you're doing from an operational perspective. And you want to make sure you have that consistency, so that way you don't have your operations teams, your development teams, out there trying to recreate the wheel there. I'm actually going to turn off this mic. It's actually kind of hard to talk on this mic. So with that, the idea behind DevSecOps is it's going to enhance your security, right? So as you start shifting left with automating that DevSecOps, looking for those vulnerabilities instead of, like, for example, when I used to be a configuration manager, I'd work with developers, we'd cut the releases, we'd take it over to the high side, deploy it, and we'll have our work with the IA teams. They would scan it, and then we'd find out, oh, it's a vulnerability. So with DevSecOps, you're introducing those vulnerability findings much earlier throughout the life cycle. So that way, like for example, if I find a bug or something in a software that a developer worked on, I'm not, if I do it reactively, they're most likely already moved on to something else, for example. Whereas if I'm doing it proactively, they are able to quickly address some of those security discrepancies or the security risks that you have available. So that's sort of the idea behind DevSecOps with your automation. And some of the benefits of DevSecOps is you're going to be able to deploy faster. Like I said, once you have that standardized pipeline that you have available, you're going to be able to deploy a lot faster because you're going to have that consistency across that environment.
It's going to help with things like your mean time to recovery, your mean time to detection when it comes to different security risks that are out there, for example. And then you're going to, just reiterate, you're going to have that auditability, that traceability when it comes to your operations and the content that you're releasing. And then with that, you're going to have most likely your code, or you should be reviewing that code, having those conversations around what's being released, how it's being released, and just having that extra set of eyes in addition to that scanning that you have going on. So from a Ansible perspective, is anybody in here applying DevSecOps for your Ansible automation content? Are you doing like scans? What tools are you using?
Well, I would just be using, you'd probably scan it over, double checking the network systems. You'd be using all the different vulnerability assessment tools. And then about that point, you would then be writing the code, running it probably through GitLab first, and then probably having it probably have SNCC run through the code, and then applying it using that. But definitely that Ansible lint right there is definitely the biggest thing. There's one other problem is not just you want to make sure it's secure, you also want to make sure it's simple and elegant so you don't have future vulnerabilities.
Exactly. I'm glad to hear that because honestly, when I looked out there around what folks are doing across the industry, I didn't see a lot of people talking about it, but I knew it was important. So one of the things I wanted to do, just based on the conversations I've had with customers, with partners, I want to introduce some additional concepts because when it comes to security, I want to say most folks just think about the application. They're not necessarily, unless you're working in a highly regulated environment or government environment, you're not really worried about application or security at all layers. So when it comes to security in DevSecOps and security operation practice, you can apply to Ansible. You want to make sure that you're applying some of these things like you're linting your code. Within Ansible lint, there are attributes that you can use to scan for things like permissions that are too open, for example. Because if you have permissions that are too open, that could be a security risk. For example. And then you have tools like PyAnsible out there that you can utilize to perform some additional testing on top of that. For those who are not familiar with PyAnsible, PyAnsible provides a tighter integration between Ansible and PyTest, for example. And another thing, especially with, if you look at some of the things I'll mention as well around software supply chain security, you have to start signing your content as well, because how do you know what you received is actually the right content? It could be, you could have some bad actor internally or externally, that could have corrupted that content for all you know. So that's important, is you can utilize Ansible Sign to sign that content to ensure that it validates which you're, that bill of materials that you are utilizing, for example. And you want to take these practices, but also adopt security as code to your practices as well. That means utilizing Git as your source of truth, being able to check in everything that you do or any changes that you make should be checked into some type of centralized repository such as Git, maybe using GitHub, GitLab, whatever source control repository that you're using. It's always a good practice to utilize those to make sure that you have those traceability in an event there is a change, and if some issue is detected, you have that traceability, and Git is that source of truth. And from an adoption standpoint, like everything, I like to always apply the whole crawl, walk, run approach. Start small, try to iterate from there. Rome wasn't built in a day, so neither is this going to happen. So you have to look at ways to first get that, have that culture shift, have those conversations with your teams, your different teams, bring them together and try to unify your operations to a point where you have consistency in terms of the pipelines that you're deploying, in terms of the automation that you're using, whether that's Ansible, whether that's Puppet, Chef, any tool out there. Try to look for ways to standardize on the tools, but also, in addition to standardize, you want to minimize some of the tools if you can in your environment. That helps keep it simple. For example, I know we don't always have the choice or the luxury of deciding, oh, I'm just going to move on to this new application. I'm not going to maintain this brownfield application anymore. So sometimes you may be stuck in a situation where you're still utilizing that legacy technology, but you're also utilizing modern technology. So you got to account for those situations or those edge cases as well. But I can't stress enough that from an operational perspective, try to focus on that cultural shift, getting that buy-in from your different team members. Also, looking at ways that you can standardize. Does anyone in here, do you have like communities of practice internally, or are you having like either like conversations around like joint interests like automation? Is anyone doing that? That's another way. So I speak with a lot of different companies on a monthly basis at communities of practices and user groups, and during those conversations, conversations like that, for example, those are some places where you can, have those conversations. Because it's tough if you're all kind of just working siloed, you're all in your own sections, all have your own priorities, your own missions. Try to look for ways that you can come together, sort of like we're doing here, right? To kind of share information, have those conversations, as well as, just look for ways to standardize. I can't stress that enough.
Before you go on,
Yes.
can you say a word or two about the mechanics of Ansible sign? If we wanted to implement that in our environment, are we talking about like bringing in a collection into our control hub, or are we talking about setting up new practices? Does it have an external component? What does it look like at an implementation?
Yeah, that's a good question. So with Ansible Sign, you just pull it. It's just a Python package that you can pull in and install. It's also included, depending on what version of Ansible you run, it may be included in that as well. But if you're outside it, depending on, do you know which version of Ansible you're on?
Off the top of my head, no, because I've had my head in Ansible automation platform.
I see, okay. Yeah, I'll share some information with you afterwards on that and tell you how you can pull it into the environment if you don't already have it. But there's always more than one option depending on, I know some people aren't always on the latest and greatest Ansible and stuff like that as well. Cool, thanks for that question. Now just, further looking at some ways that you can automate with Ansible or enhance the security around your environment with Ansible. So I know we may have a different audience in here, but on the government side or the federal side, I typically see folks having to implement what's referred to mostly as STIGs, and that stands for Security Technical Implementation Guide. And I know that with a lot of folks that I talk to, it's kind of the bane or one of their major pain points, just working around the STIGs, implementing STIGs. Look for ways that you can, even if you don't even have that requirement, I would strongly recommend look for ways that you can incorporate some of those guidelines that's in STIGs as far as like locking down your systems into your automation. And if you have findings with STIGs and if you have OpenSCAP installed, you're able to, STIGs or OpenSCAP's able to spit out those remediation scripts that you need in whatever format you need, either Bash or Ansible content. It's really, they've been around for a while, and like I said, there's always a lot of challenges when it comes to STIGs as far as like accessibility, but also sometimes just implementing the sheer amount of controls that they have, that can be daunting. But one of the ways that you can look for some synergies there with Ansible is look for ways you can create automation content and try to STIG your machines early in that process. So if you're building out like golden images or images of your infrastructure, try to stick those as early as possible throughout that, and even have an automated process to do that would be helpful as well. So from an Ansible adoption strategy or Ansible DevSecOps adoption strategy, just want to reiterate, you can look for ways to standardize your processes, your tools. From a workflow perspective, this is where you're gonna, I would say, you get a lot of gains at. If you're not out there, if you don't have folks, everybody's out there trying to reinvent the wheel, they're trying to do their own thing, that's gonna create a lot of challenges when it comes to accelerating some of those outcomes that you're looking for. Now, if you shift towards the model where you have teams that are creating content, sharing that content out to other teams so they don't have to reinvent that wheel, that's some areas where you're going to be able to create some synergies and some accelerated outcomes. And as I mentioned, if you have a if you still have the challenge of maintaining legacy applications, that's okay. Just account for those situations where you can, but try to be agnostic as possible when it comes to when you're creating your automation content. Try to use like variables and stuff that that's not hard coded specifically to one environment. Try to implement it in a way where it could be reusable. Focus on those reusable aspects. The benefits of all this is you're going to see a lot better. You're going to be more efficient when it comes to implementing security in your environments. You're approaching it from not only the application layer, but you can approach it from the infrastructure layer. Also, those day two operations that you're doing on those servers, whether that's just basic locking down your systems. That's something that's probably at least not going to go away anytime soon. Maybe sometime in the future it may go away. But right now, this day two operations and security is always going to be a huge challenge, a huge issue. And just look for ways you can apply some of those DevSecOps principles to your automation and everything that you do within your environment. Now, from a DevSecOps tool chain perspective, this is just a list of mostly open source tools. I tried to focus mostly on open source tools to give you an idea of some of the tools that you would utilize throughout the DevSecOps process. Where Ansible fits in is going to be on that infrastructure as code side, security as code side. Also, it's going to fit in on that deployment side. So, as you work through all these your DevSecOps pipeline, and as you once everything's been blessed, it's ready to go, you can utilize Ansible where it makes sense to deploy those changes that you need to deploy. If you're utilizing containers, or if you're probably adopting Kubernetes, you can still use Ansible, but it's up to you, depending on how your operations is. Does it make sense to add that extra layer to your deployment, for example? I know we have HashiCorp here. HashiCorp and Ansible are better together. We have modules out there that you utilize. HashiCorp's probably going to cover some of that later, but just know you don't have to necessarily pick between one tool or the other. While Ansible can do some of those day one operations, I would say for the most part, unless you're a small shop or you're not too worried about the risk there, I wouldn't recommend it for that. I would focus more on those day two operations where you're laying down those server configs, you're laying down those application configs on your server. That's what I would utilize Ansible for. But if you wanted to, you can also, from a workflow perspective, you could utilize the modules that are available to orchestrate Terraform as well. So just wanted to mention that. And then there's tons of CI/CD tools out there, but if you're working in the federal government space, you're kind of limited to what's maybe in your environment. That's for a number of reasons. It could be because it's just not approved for that customer environment. So just keep that in mind. You may not be able to use the latest and hottest tools out there, but just utilize what you can and what makes sense for your environment. And if you need any idea, this is not an exhaustive list, but I'll put a link and I'll share this slide deck out afterwards where you can look at some more tools just to get the creative juices flowing in terms of all the tools that's out there. For the commercial side, there's going to be, obviously, depending on where you're working at, there's going to be a lot more options in terms of what you can utilize from a tooling perspective or tool chain perspective when it comes to commercial tools. A lot of the same concepts, just different tools, but from from a security operation standpoint, just I would also recommend, especially these days, you have to do a lot more or less. So look for ways that you can have, put some of that ownership on other teams to provide it as a service. Like, for example, at my last company, we had what we can call CI/CD as a service. My team, we didn't want to we could have ran our own CI/CD tool. But that's not our bread and butter. That's not our focus area. Why, have to worry about one more application? If there's another services team or platform services team that you have internally, try to look for ways that you can get someone else to own some of these tools, so that way you can minimize, some of the operational burden that you have to, and that you may have to endure. So this is just to give you an idea of what, some of the areas of where, how Ansible looks in practice with DevSecOps. As we mentioned, from a workflow perspective, you can utilize linters, you can do your own unit testing within Ansible if you want to adopt some of those DevSecOps practices with Ansible. And also the main place where Ansible is going to be utilized is going to be the deployment side. So after everything's ran through that pipeline, from security analysis to unit testing, code coverage, SaaS. For those who aren't familiar, that's SaaS is static application security testing. That's basically checking for some of that low-hanging fruit that you may have out there from a security perspective. Then you have dynamic application security testing, which is more, checking for those binaries, those runtimes, some of those complex scenarios when it comes to security. But when all that's said and done, Ansible can be utilized on that deployment side of your DevSecOps pipeline to deploy those changes to your environment. So here's some of my favorite papers and briefs. One of my favorite papers, Executive Order 14058. That focuses on the customer experience, the user experience. That's very big in the government these days. There's entire executive order on it. We take a look at some of the incidents that have transpired over the last, I would say, few weeks or maybe month, not to get too specific, that interrupted the customer experience. When you have a security tool that interrupts the customer experience, that's huge. That could have been prevented by applying some type of practice like this, where you're trusting and verifying that stuff before it comes out. And that's, a good case of how security can, impact the customer experience. And that's why I mentioned it today. NIST also has some guidelines and some guides out there. I like NIST because, they're not while they may be a government agency, they're not focused just on the government. They're focused on, a lot of what they say or what they recommend can be applied in the commercial space as well. So it's something to check out. And then one of my other favorites is Executive Order 14028, which focuses on the nation's cybersecurity and supply chain security. You probably heard that one mentioned a lot. I would definitely recommend checking that out if you're not familiar with it. And then just to diversify a little bit here, OWASP 10, that's been around for a long time. That's going to, if you're a new developer or you're a developer and you're just looking for some practices you can apply from a security perspective or things you can test for from a security perspective, I'd recommend, and a lot of tools scan for OWASP Top 10 too, but it's just good to know and understand, what type of vulnerabilities, or what type of security risks that they're talking about there. So keep an eye out for that one. So just to recap, when it comes to DevSecOps and automation, the main thing is you want to make sure that you focus on the cultural aspects. Look for ways that you can standardize your workflows, your processes. Look for ways that you can partner closer with your security teams. So instead of having that reactive relationship with your security teams, as you bring in automation content into your environment, make sure you're scanning that content. Make sure it's free of vulnerabilities. Make sure it's from a trusted source, because that could be an area that's overlooked. It can be an attack vector when it comes to your systems. And you want to, look at the entire life cycle, not just layer 7 or the higher level layers or the application layer. Make sure you're looking at that infrastructure, and keeping your infrastructure or your security as code there within that source of truth, but also utilizing Ansible where it makes sense for you to automate some of that, to streamline some of that. And from an adoption perspective, look at it from a crawl, take that crawl, walk, run approach. Start small, iterate from there, and you'll be on the road to success. So here's my LinkedIn. If you want to follow me, feel free to follow me on LinkedIn. GitHub, I usually try to post useful content, so I won't spam you. But yeah, if you're interested in the content that I put out there, please follow. Feel free to connect with me as well. But yeah, I want to thank everybody for your time here tonight and your attention, and I'll open up for some questions. Yeah, sure.
I have my idea of what the phrase means, but how do you characterize day 2 server operations?
Day 2, that's one of my favorite questions actually. So anything, I'd class first. I got to talk about day 1. So day 1 is server provisioning. So whether that's bare metal, whether that's in the cloud. That's what I consider mostly day 1 operations. Also in day 1 operations, it could be some firewall things in there, some security things that you had to get approvals for, but that also could be down the road. So day 2 operations are those operations that you do after the server's been provisioned, once you can log in and access it. So things like your configuration management. So install an additional set of users, or change or point your server to a certain Yum repository. Any operation that takes place on top of that server, whether it's application deployment, configuration management, that's what I would consider day 2 operations.
And that's exactly what I thought. And the reason I asked the question is, it's sort of twofold. One is to say, do you think, or when you're setting out writing your automations and writing playbooks, writing inventories with variables, do you think it's necessarily a good or safe or practical thing to separate the day 1 and the day 2, or do you think that it just depends on the environment and whatever practices are already in place?
Oh, you mean from like an operational perspective, or like a tool perspective, or kind of both, or all of both?
I mean operations, because I think that we're looking at all the tools universe as being whatever you can automate.
Yeah. I would say it's going to depend. I mean, it's going to depend on a number of factors. One of those factors is going to be how mature your operations. You may just not simply be there yet to be able to deploy a server, utilizing those in an automated fashion with something like Terraform, but also subsequently, from an execution standpoint, run Ansible or some configuration management tool all in one swoop. You can do that. I've seen it done both ways, and a lot of it depends on just the project that you're working on. Does it have that capability already? Does it exist? If you do have it, I would say for the most part, I really haven't seen any challenges. That's pretty much the nirvana, I would say, from an operations perspective. Be able to do day 1, and day 2 actually on the same day. So changing the name.
See, my whole thought process behind that question stems from my frustration that my team makes day 1 and day 2 completely different suites of playbooks and inventories, and there are portions where they log into a web UI and type things, where they do things by hand, and I feel like, and I keep hammering home, every time you do something by hand, you've introduced human error. Get rid of that. And so I've been trying to get them to write a role that will go from provisioning to releasing the VM, like you say, commodity to whomever requests it, with all subscribed to satellite. We use CIS benchmarks instead of state, it's the same game, right? You're talking about the benchmark. All the user creation, all the subscription to tools that it might need, like a Nessus agent. I want a single flow, because anything where there's 2 steps in between is an opportunity for my contractors to make an error.
Yeah, I see what you're saying, and it's possible. It's possible. You know, if you want to have a, if you'd like to have a follow-up conversation, you know, we can talk about it more. I've done this, you know, I don't know, like countless times. I've just recently done it with a group of folks here recently. So happy to, you know, help see how we can make that a reality for you.
Yeah, I will have more questions.
Sorry, you wanted to say
Yeah,
something?
just want to comment on your question, right? So there's 2 factors there, right? First is how immutable is your operation, meaning that are you always pushing incremental changes, or do you not allow that? And you have, hey, this is the golden image and don't touch it. If you need an update, we're going to update the golden image and deploy that. Or is it, am I doing incremental changes? So that kind of helps you differentiate. Am I going to do a day 2 off specific thing with Ansible, or am I just going to sweep and change every time when I release a new site?
And I'm going to start out with the admission that I do not know what a hash is. Cool.
Okay, we'll talk about it in a second.
But having said that, I'm lucky. I'm in a small agency where I have a lot of latitude. Things are not. The only thing that's set in stone is what I release has got to be secure.
And so the second
We have components in the cloud, but they're more on the Windows side, so not my problem.
So the second piece to that is your workflow, right? So are you allowing users SSH access, or do you start to put them in a framework where if you need an update, you push code, we'll check that code. If it's good, we'll commit that code in and push that.
That's a very good question, because it's a direction I'm trying to push.
It'll take time to get there.
And one of, oh yeah, I've been there for over 10 years. It'll take another 5 hopefully.
Yeah. That's like,
We're dealing with whole commands in the Navy that are having that exact same conversation. How do I change culture? How do I, because I mean, the conversation that we're having with some of these Navy accountants. How do we use Ansible and HashiCorp and GitLab to create a cohesive cycle of DevSecOps?
And it could be a little bit of both, right? You could start where you have the golden image, you start to decouple and break that apart into something more ridiculous. Like you're always, there's no tech there. You're automatically building every single time from net zero. Right? So you could say, hey, I'm gonna start with an image, maybe it's big, but then you start to just kind of whittle that down. As you start to break that functionality apart, and you start delivering that just in time. Hey, I'm gonna build this during the actual composite review. So I'm starting to chain it together. So you have the flexibility and power to start anywhere you want that.
I mean, I have what is probably a unique advantage that I built my department. Like, it didn't exist when I got to my agency and I built it. So I can dictate terms that a lot of people don't have the flexibility of doing. And that gives me the capacity to do exactly what you're describing, which is inch-worm your way towards a desired outcome.
And it's the people too, right? Because you got to get them to that sort of new philosophy as well. And sometimes it's walk before you run. So you have to start that way. And then as people get to know, it starts to compound.
Oh, the people. Don't ask me why it took me a year to get from Rel 7 to Rel 8. The people.
Awesome.
And on that point, from a cybersecurity perspective, as someone who's got to be an analyst, has to be the auditor, it is, you know, we always talk about the layer 8 issue. If anybody's ever worked on a help or service desk before, yeah, layer 8's another problem in cybersecurity. That's the other thing, is you have to always bear in mind the people you're going to be working with.
Right. And
Some cultures are more entrenched than others.
Is that not the truth? My lucky statement in that area is that 2 of the people in our cybersecurity division were previously sysadmins underneath me, so they're more sympathetic to me than you might see in a lot larger organizations.
That's what I suspected.
Yeah, thank you for the question. Any more questions?
okay. So, hi, my name is Gerald Dykeman. I'm with HashiCorp Federal, and you might be wondering, what the heck is HashiCorp doing here? Well, what we're going to lead up to in our conversation is this. We want to show this integration today. Now, I think it's been 6 or 7 years ago, I was up here talking about Ansible network automation. So, been using Ansible for a long time, was a principal architect for Ansible at RedHat, been there for 6 years, moved over to HashiCorp, and now doing HashiCorp things. So we're going to lead up to this, but before we can lead up to this, I need to give a quick HashiCorp overview. So, skip. So these are a suite of technologies. So we have, oftentimes people think of HashiCorp, they just think Terraform. Well, we are the company behind Terraform, but we have all these other technologies out there, similar to Red Hat, that have a community upstream project. But we do it a little bit differently at HashiCorp, is that there are enterprise features that you don't get for free. So you pay us for that. So that's the difference between Red Hat and HashiCorp, is that there are actual enterprise features we provide that's not free. So with that being said, let's get into, I'm going to focus on the 4 technologies here. Actually, let me go to the next slide. I'm going to focus on these 4 technologies. And these 4 technologies at HashiCorp make up our zero trust architecture. So we're going to first start with infrastructure, which is something known as Terraform. That's our infrastructure as code tool or solution. Then we're going to get into Vault, which is our secrets management solution. Then something called Console, which is a network service platform. And then lastly, something called Boundary, which is for user to machine access or remote access solution. All right. I'm trying to think of how much stuff I should hit. All right, let's start here. So infrastructure as code. How does Terraform work? So similar to how Ansible has these collections and modules, Terraform works off of this concept of a provider. So if I want to interface with something, some platform, I'm going to need a provider for that. So I'm going to work with AWS, I'm going to use the AWS provider. I'm going to work with VMware, I'm going to use the VMware provider. And that offers the translation for Terraform to be able to communicate with that platform or system. So similar to Ansible, we have a lot of providers for many, many platforms out there. It's almost harder to find a solution where Terraform doesn't integrate or doesn't work with rather than it does. So very similar to Ansible in that concept. So what we're talking about here is infrastructure as code. And the reason why the question comes up of, hey, I have Ansible, why do I need Terraform? Well, the main reason for that is the right tool for the right job. Terraform was designed with APIs in mind, with speaking APIs versus mimicking what operators do. So Ansible was born 10, 11 years ago now, I don't know how long ago. It was built because config management was too difficult. And it was built targeting Linux machines. So it had some assumptions. It assumed that, hey, I have access to Python, I have access to Bash. So I can do remote things, I can mimic what an operator does. Terraform was built with cloud in mind. So it's used to talking APIs, which you go from what made Ansible famous, the stateless or agentless, stateless sort of tool that does linear operations. Hey, so this operator no longer has to run this stuff to install these packages. This operator doesn't have to log in and do systemctl, start some type of service. So you mimic what an operator would do, you write that in an Ansible playbook, and now that's automated. Terraform's a little bit different. It's a stateful tool, and it's a declarative language, meaning that you provide it the set of parameters that it needs. It'll go out there and it'll figure out all the dependencies, and it'll make it so that it's at the state that you want. So that's the main difference between Ansible and Terraform. So if there's a controller or some type of API to communicate with, Terraform is usually the go-to tool. If it's, hey, I'm logging into a device to do stuff, Ansible is the perfect tool for that. Hopefully you can see that back there. So similar to Ansible, Terraform, it's just key value pairs, right? This is what we call a HashiCorp configuration language. And similar to Ansible, it's supposed to provide a standardized experience regardless of what platform you're going into. So you're going to work with AWS. Well, what are my parameters? Here's the syntax. Here's how you write it. You're working with Azure. Same syntax, same concepts. You give key value pairs. Automation at scale is simply data manipulation. It's not about writing more and more and more content. It's writing that golden content once and then feeding it different data every time. Right? Same thing with Ansible, same thing with Terraform. Yeah, that's marketing. So one of the cool things with HashiCorp, and as you hopefully explore Terraform if you haven't used Terraform already, as part of the enterprise, we have this concept of policy as code. So we have a solution known as Sentinel that says, hey, if Terraform code is only allowed to be executed by Gerald and maybe Chris and maybe John over there, and who gets to access and use that Terraform code, Sentinel comes in and says what that Terraform code is allowed to do. Is it allowed to deploy RHEL 6 boxes? No, we don't allow that.
It's only 9.5 or higher, or 9.4, I don't know what RHEL version we're on, but RHEL 9.x or higher, you can only provision it to US East 2. You can only do certain things at certain times. You can't have access list rules that open up SSH to the world. Anything that you can think of is now policy as code, right? So any policy that you want to implement on how your automation executes, right? Not just who executes it, but also how it executes, and what it's allowed to do is what Sentinel does. This is a checkbox. We integrate with ServiceNow. So this, sales makes me put that. Okay, so I'm going to skip that. I'm going to go into all the products because I want to get into the code and actually see things being executed. So that's Terraform in a nutshell. You have infrastructure as code, similar to playbooks. You define how you want that infrastructure to look, and you go ahead and execute it. And now you have a stateful understanding of your infrastructure. All right, now we're going to get into a technology known as Vault. And so these three technologies are actually the core of our zero trust architecture. So let's start with Vault, and we'll kind of see how all of these integrate together. One of the things cool about HashiCorp technology is that each of them are very deep. It's a domain knowledge level type technology. But as you integrate the technologies together, they become even more powerful. So Vault, what is Vault? So Vault is a secrets management solution based off of identity. So as part of zero trust, there is no concept of IP or borders. Everybody is an enemy, right? We assume you're an enemy, we assume a breach, so everything's based off of identity. You need to prove your identity if you want to access secrets. And secrets can be passwords, tokens, API keys, anything sensitive you want to protect is now all brought into a single location. It's known as Vault. So three main pillars of Vault. First is identity-based authentication and authorization. So that bottom left there, Vault isn't an identity provider, meaning Vault's not your Active Directory, Vault's not your LDAP, Vault's not your IAM. Vault is the broker or the central identity broker for those different identity providers because we want to eliminate something known as identity sprawl. So not eliminate it, but make it easier to manage. So we don't care what identity providers you have behind the scenes, Vault becomes your single source of entry for accessing secrets. So once you have those authentication pieces in place, now you actually secure the thing. You secure your secrets. Like I said, passwords, certificates, tokens, anything that you want to protect. We're going to see some of those things being consumed by Terraform and GitLab and Ansible today, but Vault is at the center providing all that data. And once you have that, Vault also acts as your encryption as a service. So it can actually encrypt data on behalf of the developer so that you move the responsibility of cryptography and encryption away from application developers. Right? It's very difficult. They oftentimes don't do it well. And let Vault handle that. Again, based off of identity. All right. Let's skip all this. Okay, core concept is zero trust. Always keep a moving target. Always assume a breach. Always enforce authentication and authorization for everything and trust nothing. So as part of that concept, dynamic secrets is a core principle of how Vault operates. And what I mean by dynamic secrets is we no longer have long-lived static secrets. We no longer have long-lived certificates, year-long. We don't have other things. I actually saw this last week, or was it 2 weeks ago? I was on my personal AWS account. My API key was 1,400 days old. So, don't do stuff like that, right? That's why Vault exists, because you don't want to do that kind of stuff. So I did change it, but that's the kind of stuff that we want to just create these credentials just in time, short time to live, and let it die. We don't need it to persist. So with that concept, first is databases, dynamic database secrets. So when a user or application or some type of service needs to access the database, whether it's a read operation, write operation, whatever operation it is, they will first need to prove their identity. Once they've been authenticated, if they are authorized to access this database secret, which could be a username, password, which could be a token, then Vault will reach into the database, create that temporary credential with the granular policies applied, and send that back to the application or user. And they'll use that, and then it'll die. So again, short-lived, just-in-time secrets. Same thing with service accounts. You'll see later in the demo where Terraform actually reaches out to Vault to say, hey, I need to provision something in AWS. Here's my identity. I'm Terraform. Here's all my information. Give me credentials. And Vault says, okay, I know who you are. Here's the temporary credentials I'm going to give you that last for 1,200 seconds. Go ahead and use that. right? So I don't even know the credentials that Terraform is going to use, nor should I, right? I don't need to know those. Let the machine-to-machine communications handle all that. So you'll see that with AWS dynamic credentials later in the demo, but same thing with service accounts. So as containerization becomes more and more common, right, even in the public sector space, there's a problem that needs to be addressed is Kubernetes secrets. So Kubernetes secrets is a way to encode sensitive data that you want to protect. And the key word there is encode, it's not encryption. So what we do is we offload that responsibility to Vault and let Vault handle encrypting sensitive secrets and then provide that to the workloads when they need it. Right, so one other addition or one other powerful feature in that workflow is that workloads can actually dynamically get new secrets while they're up and running. Right? It's not just, I'm going to load these static secrets one time and I'm done. It can constantly interact and get new secrets or updated secrets. So Vault becomes the go-to solution for Kubernetes secrets. And when I say Kubernetes, right, OpenShift secrets, Vault will be managing that. There's two ways of deploying Vault with OpenShift. One is something known as Vault injection. So Vault will inject secrets into the pod or into the workload, or you can use the Red Hat certified Vaults operator. Right, so both ways to address that. Same thing with certificates. So when I was at Red Hat, I didn't use Vault much. It was mainly Terraform, right? Terraform and Ansible. Vault is a humongous beast of a product. It does so many things, it's ridiculous. So another thing it does is certificates. So Vault can actually act as your certificate authority, intermediate certificate authority, however many levels you need that, and also your last mile, or the thing that actually loads the certificate onto your system. So there's multiple ways to do that, but a common way is you have a Vault agent that monitors the lifetime of the certificate, and then it will reach out automatically to replace that certificate when it's going to expire soon. So certificate management, don't even have to worry about it. Let Vault handle all that. In addition, now you have short-lived certificates that Vault's just going to automatically rotate for you anyways. Because, like I said, we always assume a breach, right? So malicious attackers stole our certificate and they have access to our stuff for a very short period of time to do anything east-west of significance. Data encryption. So this is part of our advanced data encryption concept. We also do just pure encryption, meaning, hey, here's my text, encrypt that and send that to me. And then now I can put that in the database. That's the most basic form of encryption. These are things like, what you see on the right there is format preserving encryption. So credit card numbers, social security numbers, they have a specific format, whether it's due to compliance, whether it's due to database restrictions, you need to adhere to that format. That's where format preserving encryption comes in, let Vault handle the encryption of that data. One of the problems, very not, how do I word this? It's possible with enough computing power to reverse that, right? Because that's pure encryption. Right? So there's some mathematical formula that goes in there to spit out that different encrypted data. Now, if you don't need to adhere to some type of format, we have something called tokenization, which is a reference to the data that has no mathematical correlation, so it's irreversible. So if that's an allowed deployment method, we also have tokenization. And lastly, we have a concept known as data masking. So data masking, think of it as, let's say I have a database. I want to provide production-like data, or as close to production-like data to my third-party developers, partners, test it, break it, do whatever you need to. Instead of giving them production data, you can mask that data, obfuscate it, and give them real lifelike data, but it's not the actual data. So that's data masking, that's the third piece of encryption. Anyone using KMIP? So KMIP is a protocol for managing keys. And so oftentimes, you have all these different solutions for managing different keys. And a common example is, let's say you have VMware and you want to encrypt your VM data. Well, that key that encrypts the data usually lives in VMware itself. So if VMware is compromised, that key is compromised, everything's compromised, it doesn't matter. So we're separating the responsibilities there and saying, hey, VMware, here's your data encryption key to encrypt that data. Now I'm going to encrypt that key inside Vault. So it's speaking the KMIP protocol. So now Vault becomes a central location for even managing all your keys. Actually, this is a good use case. So I do a lot of work with Navy and Marine Corps. And one of the requirements is how much weight you can put on a ship. Right, so Vault is software. So now they can have that KMIP functionality, which is usually hardware driven, in Vault, right? In addition to all the secrets management, all the other stuff it's doing. So less hardware they need to deploy. So another integration point here, and this is the integration I'm going to show you in the demo, is Terraform reaching out to Vault to get credentials to then execute to whatever it needs to do, and then that credential dies. So Terraform itself, the enterprise version, has a built-in Vault for sort of day zero secrets. I'll show you that once we get to the demo stuff. But you want an actual central Vault, a true enterprise deployment of Vault to handle all your secrets, right? And one of the things with Vault is that it is absolutely mission critical. If that goes down, everything's done, right? So we can't let that machine die or that service fail. So enterprise starts to talk about all the ways we keep it resilient, but Vault does become a very critical component of your infrastructure. All right, really quickly, let's get to Console. So what is Console? Console is a services networking platform. And what I mean by that is, as part of Zero Trust, Console's main job is to secure machine-to-machine communication. Application A, application B, they want to talk. We make sure that they prove their identities too. Right? Machines also have to prove their identity. And then we can bring up a secure tunnel between them. So as part of Console's functionality, first is catalog and discovery. So especially as you move towards more microservices architectures, larger deployments, things go up and down all the time. Knowing what you have deployed, what services do I have, what applications do I have running, and how do I reach them, and what's the health of those applications and services, that's all cataloged and discovered in this console deployment, this console architecture. So once we know what we have deployed, then we can say, all right, who gets to talk to what? So now we need to secure it, and we call this the service mesh. I'm sure you've heard of that term quite a lot. If you've heard of a technology known as Istio, think of it as a similar type of concept here. What we're doing is we're securing machine-to-machine, service-to-service communications. And how we do that is, again, based off of identity. In this case, these are applications and services, so the identity is a certificate. So when web app wants to talk to API app, they present their certificates to prove their identity. Then those certificates are tied to something known as an intention. Think of it as an access list. Is web app allowed to talk to API app? And if they are allowed to do so, then we bring up a mutual TLS tunnel, and now they can communicate. So that's the whole point of Console, is this service mesh capability, bringing secure communications to your applications without having to re-architect a lot of stuff. Now, this works in Kubernetes, this works in OpenShift, but it also works with VMs and bare metal. We don't care about the platform. If you want to bring zero trust principles to your VM, Console can extend that service mesh capability to your VMs or bare metal or whichever deployment you want. Here's another integration, right? So I said certificates. Console uses certificates for identities. So who's managing those certificates? Well, Console has a built-in certificate authority, but again, the certificate authority also being the entity that does all the stuff is not as secure as offloading that responsibility to an actual certificate authority and letting that certificate authority rotate the certificates of these Console workloads. So when a workload is deployed, it's deployed with a Console client. And this client, or this proxy, is what handles the certificate rotation and identity brokering. So now Vault's going to just talk to that proxy and rotate those certificates. So that's another integration between our technologies. Now another integration is Console and Terraform. So I said, hey, we need a registry that discovers all the services that are deployed and where they are and how they're reachable. Well, as things come up and things go down, there's physical infrastructure that also has to be updated. If I deploy a new service, I need to maybe update a firewall rule. I need to update a load balancer, member pool. Now Console can sync that data to Terraform and let Terraform do the infrastructure as code and bring the infrastructure up to what Console understands. So now they stay in sync, and we actually call it Console Terraform sync. So you can take advantage of the integration between Console and Terraform to let Terraform know to update stuff and delete stuff and add stuff based on what Console's registry sees. So now your infrastructure is in sync. And lastly, this is just access into the mesh or into Console, right? So you have Console deployed, you have all these cool services going on. How do users outside or external to that access those services? They come in through the API gateway, Console API gateway. That's all that is there. Okay, I'll touch on this really quickly. So as you start to have more and more deployments, and again, you're adopting cloud, hybrid cloud, multi-cloud, all that good stuff, you're going to have these deployments everywhere, and they need to connect somehow, right? And share services and share data. So the initial iteration of this concept was something known as WAN federation, meaning that I assume that I'll have connectivity. Of course, it was made for commercial first, right? They have internet connectivity, everything. So they assumed that everything was up. They were communicating. So you had one primary administrative domain for all your clusters. In theory, that works great. A lot of organizations, the huge ones, they have deployments everywhere, right? So having one IT organization manage and maintain all those different clusters that are deployed all across the world made sense. Now, as you move into other use cases, especially DoD, federal, public sector, you're not going to share those administrative domains with Camp Pendleton, with Australia, with Japan, with South Korea. You're not going to just have America handle all that communication. So each entity or each mission partner in this case has to be their own console cluster. So we came up with this concept of cluster peering. So let's say I need to peer with, because of some activity, I need to peer with South Korea. Well, we can bring up our console peering connection, share our data, and then disconnect it when it's done, but each entity has its own console deployment, so it continues to operate. Right? You don't need to have uptime or full connectivity all the time to cluster these different console clusters together. Now, why that's significant is if you start to think about even more unique use cases, and I like to tell this story. So we did work down at Coronado with the Navy SEALs, and their use cases was, hey, I want to deploy a swarm of drones, and each of them their own console cluster. I need to start to map out the enemy territory or whatever activity I need to do, and as I get closer to enemy territory, I want to dial down the chatter, or in console world, we call this protocol gossip. Console's very gossipy. It exchanges all this information, health information, reachability, blah, blah, blah. So we cut the connections as we get closer to the enemy territory, map out whatever needs to be done, come back, peer all up, and now you have a better understanding of what you're getting into. So the application goes from data center to data center clustering to drone clustering, ship to ship clustering. Right? So all the sort of concepts you can think of can be applied to so many different applications now that we allow for connections to be severed. Okay. And I'm doing a lot of talking. When am I supposed to stop, do you know?
I think we're going to, I said 30.
Okay. If it's boring, you can just leave. I won't feel bad. One last thing, let's get into boundary, and then I want to get into the demo piece. So boundary, so now that we talked about machine to machine, right? Well, now we secured app to app. What about human to machine, right? And this is something that's more well thought of and more well known out there. There's what solutions known as privileged access management solutions that deal with this. But HashiCorp's answer to that is a VPN-less remote access identity-based proxy. I know that's a whole bunch of jargon, but basically remote access without the concept of VPN. So what do I mean by that? If a user usually needs to access a device, they would open AnyConnect or some type of VPN solution, connect in, put in their credentials, whatever it might be, and now they're in. And when I say in, that I mean they're on the network, right? So they're sort of free to roam about the network. They gain network access. So once they gain network access, now they need to actually remote into the thing that they VPN for. It could be WinRM or remote desktop to some Windows host. It could be SSH session to some rel host. It could be some web target. I need to log into my service now so I can submit another ticket. Then they're in to what they need to do, right? So especially if we talk about RDP or a remote desktop or SSH sessions or any type of authentication that you're doing, you're presenting your credentials again, right? So another security or attack point for malicious, all malicious stuff out there because of zero trust. So that's the normal workflow that we're used to. I VPN in, then I open up whatever I need to actually do the thing that I need to do. So with boundary, what we're doing is, okay, you authenticate using your identity. Once you're authenticated, what I'm now doing is you don't have this concept of network access. I present to you exactly the targets you're allowed to log into or access. And how you access those targets, you don't even know the credentials for. Vault is going to pass those credentials in on your behalf, so those are never exposed anymore. So that is the concept of identity-aware proxy and having those credentials injected into that workload or that target system, so those are no longer exposed, those are maintained, rotated, all behind the scenes by the organization. You don't need to expose those secrets. Again, the integration here is Vault comes up everywhere, Boundary and Vault integrating to be able to inject those secrets on behalf of the user without having to expose those to the user. So it looks something like this. User authenticates the boundary. You say, all right, I'm whoever, let me in. Once they're connected, once they're authenticated, they're presented a list of targets. And if we have time, I'll show you the boundary as well. And once they're presented a target, they connect to that target, and they're proxied over to the worker. That worker then proxies them into the target system, and Vault is injecting the secrets during that session so that the user can be authenticated into the system. So, again, all part of zero trust, right? You don't expose credentials you don't need to expose, reduce the attack surface. And what this really does is, in addition to the concept of no more network access, this system is not reachable unless you come through this boundary worker, which can only be reached if you authenticate the boundary, and will only work if Vault is able to inject that secret into that boundary worker. So the way you authenticate and connect to a target system is very specific, reducing the attack vector again. That's part of zero trust. I know that's a lot of talking. So with all that being said, we're here to look at this, or talk about this. Okay, so the workflow goes like this. So I'm going to push code, and this goes back to your question. Everything should be, I'm pushing code. I'm pushing code, I want people to review it. Once they've reviewed it, they've committed it, it kicks off a pipeline, and it starts doing all this cool stuff. So in this case, GitLab, I use GitLab, you can use anything. I use GitLab as the orchestrator. And the reason GitLab is the orchestrator is because now I want to operate in an API-driven way. So GitLab is making API calls to all these systems or these solutions to kick off the next job. So it's going to first say, all right, Terraform, we got a new code update. You need to go and execute that code. Terraform goes, okay, Vault, give me credentials so I can do it. Terraform does this thing. Then GitLab says, hey, Vault, I need some data that I need to pass over to Ansible. Can you give me that? Vault does, okay, you're GitLab. I know who you are. Here's your secret. That secret is sent in an API call to Ansible. Ansible says, hey, Vault, I need some extra data so I can do stuff. Ansible reaches out to Vault. Vault says, oh, I know who you are. Here you go. And Ansible does its config management. So this is the very common workflow that most of our customers are at or moving towards. And the reason for the separation and why GitLab is the orchestrator is APIs again. Terraform Enterprise, Ansible Automation Platform, and Vault all have a lot of benefits if you use the platform, if you use the enterprise version. What we don't want to do is embed the technologies. And what I mean by that is I can execute Ansible within Terraform if I wanted to, and Ansible can execute Terraform within its playbook run if it wanted to. Now you lose all the benefits and all the security controls that come with each of these solutions, so you want to separate them as much as you can. Let infrastructure provisioning be handled by Terraform. You'll have history, compliance, audit trails, all that good stuff. Let configuration management be handled by Ansible platform, which also has history, all the encryption built in, all the credentials, who gets to do what, all the RBAC stuff. So that's why we're going to an API-driven workflow so we can take advantage of each vendor's solutions. All right, so with that, let me drink. Was that too fast? I wanted to make sure we stay on track. Okay.
Or before he moves into the actual demos and things kicking off, are there any questions about the flow that he walked through?
All right.
Gerald moves quick, so I just want to make sure that we aren't walking past questions.
So, Terraform Enterprise works out with this concept of workspaces. So this workspace holds all the data and everything necessary to execute Terraform. So the workspace that we're going to work with today is something called this AWS CI workflow workspace. So in here, it has all the stuff that I need to execute Terraform, including when an API call comes in, the code's going to be sent to this workspace so it can kick off Terraform execution. Now, one of the things I want to talk about here is that variables. There's secure data that you might need, and that's what I meant by Terraform Enterprise has Vault built in. So you can have sensitive stuff, right? Sensitive stuff in your Terraform Enterprise deployment without having to share it with others. So for example, if you use just Terraform open source, or we call it community now, if I were to do some cool automation, infrastructure provisioning, and I want someone else to do that, I need to give them all the keys to the kingdom to do it. This allows for sensitive data, whether it's API keys, whether it's tokens, passwords, to be encrypted within the platform or the solution, and then I only grant them access to utilize it. They don't have to know what it is. So day 0 way of addressing encryption and secret management is the built-in variable section within Terraform Enterprise. The real way to do it, or the ideal way to do it, is to actually reach out to Vault to grab that data. Okay, so you see in here all this information. Actually, let me start with this. All right, so I kicked this off earlier, 5 hours ago it looks like. No, I don't know when, 8 hours ago. So I kicked this off 8 hours ago, and all I did was I just deployed a simple server. And this simple server deployed a web server. And this is what we got. This is iteration 1, version 1. And so this workflow went through everything here, right? Terraform kicked off, spun up a server, GitLab then said Ansible log into that server, and config management to make it look like this. Yes?
So basically the benefit of that diagram that you have there, is the key benefit from that the fact that the secrets are injected into API calls?
The key benefit here is that when these two machines talk, they're exchanging stuff without human interaction or human intervention. I don't think I understand the question fully. Can you elaborate just a little bit?
So I'm kind of new to like these kind of processes, but like I'm kind of familiar with Terraform. So you mentioned the secret not being exposed at all, like the access keys and whatnot.
Mm-hmm.
And you mentioned that being injected into API calls.
Yeah, so what's happening here is when Terraform, so that's all TLS communication, right? So when Terraform says, hey, Vault, it's me, I need AWS keys, Vault's going to say, okay, here's your AWS key data back, and that's what Terraform uses to execute. It's similar to what you're saying, right? And here I actually say, hey, Vault, give me data, and this is a pure API call to RedHat. This one is an integrated, they have an integration there for that to work. This is more of an API call, so it's a little bit different. And the reason it's different, and I'll show, that's a really good question. I never thought of it that way. So in here, these workspaces, let's just create a new workspace in the default project. Geez, what is this? Okay, whatever. Azure Landing Zone. Let's just say I'm creating a workspace in there. Just select something. This is some new view I haven't seen. Okay, let's say I'm going to create a workspace. So I have these 3 different workflows. And so the reason I said that GitLab and Terraform are actually doing an API or a version control workflow where they're communicating with each other. The way I'm interacting with Ansible is a pure API call to Ansible to execute Ansible stuff. So depending on the platform you're working with, there's going to be different integration points. This is an actual integration with GitLab. The pipeline call on Ansible is just an API call.
Thank you.
Yep. Good question. Okay, so this is our iteration 1. It went off, it did all the stuff. Ansible went in, it installed those packages, it deployed my HTML template, and now I have it. So let's make some changes. Okay, let's get into, so like I said, everything is just variables. Everything is just key value pairs. Once you have automation set in place, all you're feeding it is different data. That's all you're doing. So you need more servers, we'll just give it more servers that you want it to iterate through. And now this works this way is because I'm looping through this data and I'm telling it to build. But you can have it a flat data structure, but it really comes down to what type of data model do you want to maintain and how you maintain that, and what data are you feeding your playbook or your Terraform code. So let's spin up 2 more servers. Oops. And let's change the deployment. So within Ansible, I have my variables here again. It's all data I pass into my Ansible playbook execution. So in this case, I'm going to say, hey, we're going to go with release 2. Now let's get to Git, right? So the workflow should be like this. So a user, well, it should be a little bit better than this, but the whole concept is I updated code, I'm going to add that, I'm going to commit that. You should never commit to what we call main or master, but I'm doing that because it's a demo. But I'm going to go ahead and commit this and say, hey, we're ready for release 2, right? Whatever message you want. Make it a very descriptive and a meaningful message. And then we push that data. So now this data has just been updated in my repository. So if we take a look here, we see that just now these 2 these two paths, or this file and something in this path has just been updated. I updated an Ansible variable, I updated Terraform variables. So what that should do is then that should kick off a pipeline. So we see a pipeline got kicked off. So what does this pipeline look like? Here are my steps that I built into my pipeline. So uploading configuration, this means that I'm sending the updated data to Terraform. So if I go into Terraform, I should see that, hey, something's happening here. Now a plan just got kicked off, right? So the pipeline reached out to Terraform and said, all right, we're ready, here's new code, go ahead and execute it. So Terraform has two phases. First is the plan phase, meaning, hey, here's what's going to change if you execute this code. And then it has the actual apply. It applies those changes. It's similar to dry run or check mode in Ansible. As part of the enterprise feature, you get this concept of cost estimation with cloud, if the cloud permits it. Right, so with Gov Cloud, you really can't do this, but with commercial cloud, you can get cost estimation where you're about to deploy. It's about to deploy it. It should now then say, all right, everything's good, here's the change, here's the cost estimation, here's what will change, we're gonna add 2 more servers, and now it's applying. So, while it's doing that, let's take a look at the API keys it's using. Right, so you see all these variables in here, and this is because this is a direct integration that's built into Enterprise, is Terraform being able to talk to Vault. So they bring up mutual authentication by providing these variables and this data so that Terraform gets access keys. So where is that access key? Well, let's log into Vault. Okay, so if we look here, it says, all right, we're going to go to, so Vault works off of this concept of paths. Everything's a path. And this is a mount engine. So I'm going to use the AWS mount or AWS secret engine. I'm going to use the assume role method to get an AWS secret. Okay, what does that mean? Well, in here, I have my AWS secrets engine. I have the AWS role, which is the role that I tell it here, AWS role. So it's going to go into the AWS role. And it's going to say, I'm going to use the assumed role, right, which is assumed role. And I generate that. So now I have actual API keys. If you're fast enough, you can actually use this to provision stuff in my AWS infrastructure. But these are actual keys that just got generated on a 1200 second duration. You can make that shorter or longer. But the whole concept here is, I didn't inject any keys into anything. I don't know what the keys are. What actually Terraform's using, I don't know what it is. Right? This is new keys I generated just now based off of my identity, which is my username. And then it expires after 20 minutes is fairly long if you're just doing pure automation, but you get the idea. This is all done behind the scenes. So, as part of that, let's see what happened. So I deployed this, so 2 new servers came up, right? We have 3 servers total, but Terraform understood the state that, hey, this server already exists in your cloud. We'll need to deploy these 2, so deploy dev server 2 and 3. Now that I deployed that, now GitLab, as part of this section here, GitLab logs in to retrieve Vault secrets, or it sends an API call to retrieve Vault secrets. So what that secret is in this case, we're going now into a different secret engine. We were just in the AWS secret engine. We're going to get into the KV secret engine, key value pair secret engine. So in here, I have a specific policy that I allow GitLab, when it reaches out, it can only get into this secret, and that's it. All these other things it can't touch, right? And that's based off a policy tied to identity. So it gets to come in here and it says, all right, what am I doing? Oh, I want to access this variable or this secret. So as part of the API call, GitLab sends this data over to Ansible to use. And without getting too much into code, I'll try to show you that here. So this is where the API call happens as part of the workflow. This is where GitLab is going in and saying, hey, I need to get this variable, the Ansible var that you just saw, at the key value mount in the GitLab secret. So to translate that again, in the key value mount, I need to get the GitLab secret, and the data I want is Ansible var, which is this. So then, as part of the API call to Ansible, I give it this data here. I can't remember. I'll show you in Ansible. So In Ansible, what it received was that API call that had the secret as part of the API call extra variable. So you see here, as the first job, I just tell it to debug this variable. This is what GitLab just sent over to Ansible. So Ansible now has that secret. But as part of Ansible's execution, just to show you on that line, I'm simply telling it to, hey, push that var out. Vault_var is the actual extra variable I sent over. In here, it's what I'm sending as an extra variable that it's just simply displaying that. So as part of the execution, now as part of the Ansible run, I use a module to go reach out to Vault to get data as well. So I'm using the Vault KV get module, reach out to Vault, extract data, and that data is now this one. I needed to get this data. So why is that data important? Well, as part of my template, when Ansible goes in and it does its thing, you can see here, it says, all right, I'm going to populate this section with the secret data of Ansible. That's the secret that it's pulling from Vault. Right? So data.data is when you start using an API call versus something else that .data gets appended. But if you want to look at the variable, Vault. So this is the API call that actually gets sent, right? So this is just a JSON object, .data.data.Ansible, and that's actually what's being sent over. And that's what it's using to template out the web server. So if you see here, .data.data.Ansible, .data.data.Ansible. So now if we look at our web page, let's go back to their server. We see the updated version. This is release 2. We see that, in this case, it's just web data, but we see that injected information that Ansible reached out from Vault to, and then the second iteration on a different server. So now we have 3 servers up. We have Ansible doing what it needs to do, and it reached out to Vault to get that information. All right, did I miss anything? Oh, one more thing with Ansible. So what the workflow I showed you is Ansible execution reaching out to Vault. There is also built-in integration between Ansible platform and HashiCorp Vault to have those credentials or those secrets injected automatically. So if you see here, this secret lookup credential and this signing SSH credential, those are integrations that are already built into the platform where you can communicate with Vault to retrieve stuff. All right, so this would be the more secure way to do it. I was just showing you the Ansible just execution way of pulling that secret. Okay, any questions? I know that was a lot of stuff. I think I'm done. Oh, it's 7:30 exactly. So that's all I had prepared. If there's no questions, thanks for sticking in there. And yeah, let us know if I can help with anything. Cool, thank you.